So what is this question about? So this question is once again about the scores data set, which is a list of dictionaries as given here. So each dictionary corresponds to one student. The student scores are present in the dictionary for various subjects. Okay, so this institution is what it's doing is that it's allowing students to create student groups for subjects, different subjects. But then there are some constraints that it imposes on these groups, right? So there are three constraints, or rather two constraints. A group should be associated with a particular subject, so you can't have a group where group of students come together for both physics and chemistry, right? No, you have a physics study group, let's say. Now that is the first constraint, right? A group should have a particular subject. The second constraint is that the difference between the scores of any two students in the group should be at most some number. Okay, so what does this restriction mean? Okay, so let's take this example. Let's say you have a group. Let's say you have a group of students whose marks are 10, 20, so until 80. Okay, so maybe I'll not call this a group. Let's say these are the marks scored by all students in the class in physics. Okay, so this is the physics marks of all students in the class. So there are 8 students, and these are the marks of all 8 students in the class. So now I'm going to form a group. Okay, I'm going to form a group here. So let's say 3 students come together and form a group. So the students are 30, having marks 30, 50, and 70. Now the question is this a valid group? The first condition to be satisfied is that they should all focus on the same subject, which is what we are doing here, right? We are only considering physics as the subject, so that condition is taken care of. The second condition is the difference between the marks of any two students in the group should be at most mark limit. Okay, some mark limit. Let's say that mark underscore limit is 20. What does that mean? It means take any two students in this group. Okay, the difference between their marks, difference here means positive difference, right? So the difference between the marks of any two students should be less than or equal to 20. So let's take 30 and 50. What is the difference between them? The marks, the difference in marks, it's 20. Okay, so this is less than or equal to 20. Therefore 30 and 50 being in the group is fine. So you could reach can we reach the conclusion that this group is a valid group? Not yet. You have to take every pair of students, right? So take 50 and 70. These two students, the difference between their marks is 20. 20 is less than or equal to mark limit. So far so good. But then we have one more pair remaining, which is 30 and 70. Okay, the difference between their marks is what? 40. So 40 is greater than 20, which is greater than mark limit. Therefore, this is not a valid group. Okay, so this is not a valid group. Okay, so that is the conclusion. This cannot be a valid group, and it does not satisfy the second constraint. Now let's look at some valid groups. So one valid group is 10 comma 20. Okay, now here's the question: can I add the student with marks 30 into this group? Will it still remain a valid group? Let's see. So the difference between any two students, any pair of students, the difference should be less than or equal to mark limit. So if you take the pair 10 20, that difference is less than mark limit. 20 comma 30, that difference is less than mark limit. 10 comma 30, that difference is also less than the mark limit. So this group is a valid group. Okay, now let's go back to the question. What is the question asking us to do? You have to find out the largest possible group for this subject with this mark limit. Okay, you have to find out the largest possible group in this subject with this mark limit. Okay, so I'll now go back there. So first we'll discuss the algorithm and then we'll start coding. So how do we do that? How do we find the largest group? See here, 10 20 is one group. Let's call it group 1. Now group 2 could be, as we just saw, it could be 10 20 30. Okay, so can I add 40 to this and make it a bigger group? No, right? If I add 40 to this, then there is one pair of students for whom the mark limit, the difference becomes greater than the mark limit. Who are those two students? 10 comma 40. Okay, so their difference is 30, which is greater than mark limit. So this is not a valid group, so I have to stop at 30. So again, I'll state this. Just pause the video once again and think why this is a valid thing to do. If I want to find out whether a given group of students is a valid group or not, the best thing that I can do is, first I'll write this down. First, sort the group in ascending order, sort the marks, okay, and look at the last or the maximum score and the minimum score. Okay, what do I mean by that? So let's take a group. We don't know if it's a valid group yet, so let's take, say, 30 comma 10 comma 60. Okay, there are three students. Again, I'm forming a group of size 3. Now if I want to know if this is a valid group or not, how do I proceed? I am claiming the following. First, sort the group. So if I sort the group, this group will become 10, 30, 60. And then look at the maximum score and the minimum score in this group. So they are 60 and 10. Find their difference, okay? Find their difference. So 60 minus 10 is in this case 50. Okay, check if it is less than or equal to mark limit. So check if 50 is less than or equal to, in this case, mark limit is 20. No, right? 50 is not less than or equal to 20. Therefore, I conclude that this is not a valid group. Okay, this is not a valid group. So what allows, so this is the procedure, right? If you can check for this, then you can determine if a group is valid or not. You don't need to check for every pair of students in a group. Okay, why does this work? Okay, so this works because take any pair of students, the difference between their marks will be less than or equal to the difference between the maximum mark student and minimum mark student, or rather the student with the maximum mark, whatever his mark is, and the student with the minimum marks, you take that mark. If you find that difference, that is an upper bound on the difference between any pair of students. Okay, I'll write this down. The difference between any pair of students in a group. Okay, the difference between any pair of students in a group. Let's say these let's call this pair x comma y. Okay, when I say x comma y, x represents the mark, y also represents the mark of some two students in the group. So the difference between any pair of students in the group is less than or equal to the difference between maximum value in the group and minimum value in the group. Okay, so you have to convince yourself that this is correct. So take any two students in the group. If you find their difference, that is bound to be less than or equal to the difference between the student, the marks of the student at the rightmost end of the sorted list, and the marks of the student at the leftmost end of the sorted list, which is what max group and min group are here. Okay, so I'm assuming that group here refers to the sorted list, but anyway, max of group and min of group will work even without that. But we will see why it is important to sort as we go along. Okay, this may be hard to understand in this case, but at this stage, but I hope the rough idea is clear. So what is the algorithm now going to do? I'll repeat the whole algorithm now. So first step is going to be to extract marks of students in a subject. Okay, first step. The second step will be to sort the marks in ascending order. The third step is going to be, okay, so this part of the algorithm I actually didn't mention. I'll just mention that now. Start from the left end of the list. Okay, this list marks. And what should you do? You can do two things, right? So you can there are two options available to you. How do I put it? So I'll have to go back to the example. Okay, so till sorting the marks, I hope this is clear. So now let me go back to a potential group. So this is the list of students, right? So this is the list. This is the list marks. Now in sorted order. So far so good, right? So I hope you're able to understand till this part. So we have the marks of some 7 students. Now what I'm going to do is I'm going to start from the left end of the list, and I'm going to make this observation. 10 meaning the student with marks 10. 10 can either be in the group or outside the group. Okay, so there are only two possibilities. So when I'm constructing a new group, 10 is either a part of the group or he's not a part of the group. So I include 10 as as the part of some group. Okay, so 10 is the first student in this group. Once I fix the first student in the group, okay, let's say mark limit in this case is 30. Okay, now I have fixed 10 in the group. Now I look at all the marks starting from 20. And for each student, I ask if the student can be a part of the group or not. So, can 20 be a part of the group? Yes, because 20 minus 10 is still less than or equal to mark underscore limit. Can 30 be a part of the group? Yes, that's because 30 minus 10 is 20. That is less than or equal to mark limit. Can 40 be a part of the group? Yes, because 40 minus 10 is still less than or equal to mark limit. Okay, so now can 50 be a part of the group? No, right? Because 50 minus 10 is greater than the mark limit. Therefore, we have to stop here. So, what is this? This is the largest group that includes 10. Okay, this is the largest group that you can form with 10 as the first member. Now, what you do once you have found out the largest group, you now proceed with the next member, right? So you remove 10 from the group. So remove 10 from the group and continue your search, right? So your group will now look like 20, 30, 40, 50, 60, 70. Now you repeat the whole process. What is this? So 20 is now the smallest member in the group. Okay, so 20 can either be in the group or outside the group. Now I include 20 in the group. Okay, and now I start asking if these members can be in my group or not. So 30 can be there, 40 can be there, 50 can also be there, but then 60 can't be there because 60 minus 20 will be greater than the mark limit. So in this way, I can keep building my groups, okay, and whichever group has the largest size, I can keep updating my group size variable, and finally I return the size of the largest group. Okay, so I have I don't know if I have managed to convey this idea clearly, but let's now. So I have already written the code. I'll delete that, and I wrote that code to just see if whatever I've written is working. So now we'll get started. So I know what the doc string is telling me. I'll get started. So for first we get hold of all the marks in this subject. Okay, so for each student in scores data set, okay, for each student in scores dataset is a list of students, right? List of dictionaries. Now student of subject is what? Student of student is a dictionary. So student of subject will give me the mark scored by the student in this subject. So I have to append this to marks. Okay, now I have done one part, which is to extract all the marks and store them in a list. Now what do? I sort marks. Okay, recall that that is what I did. So marks dot sort will sort the list marks in place. Okay, it will sort the list marks in place. So now marks is sorted in ascending order. What do we do next? So let me take that example of marks that we had earlier, right? So marks will look something like this. Now we need to go from left to right. Okay, so I need to take the smallest element in the list. So I'll start from that. So I'll call that start of, I'll call that variable start. That will be the smallest element in the list. Okay, now remove that member from the list. So marks dot remove of start. So I now no longer have 10 in the list. Okay, but then where is the student now? The student is currently inside the list group, right? He's the first member of the group. This is the first member of the group. So what am I doing? I am removing the student 10 from the group, from the list marks. Okay, and then I'm adding him to the group. Okay, he's now the only, so far he's the only member in group. Now what do? I start iterating through the remaining members in my list marks. So for mark in marks, I ask this question: if the difference, right? So what is the difference? Mark minus start. Okay, notice that start will always be lesser than or equal to all the other students, right? Because it is the minimum mark. So is mark minus start, is it lesser than or equal to mark limit? I first ask that question. If the answer is yes, then I can append this particular mark to group. Correct? I can do that. Okay, if it is greater than mark limit, then I don't do anything. Okay, so I don't do anything. So now I look at the length of the group that has been formed in this manner. Okay, so let's say, let us, okay, so far what we have done, we have found out the largest possible group with minimum of marks, right? So with 10 as the first member of the group. Okay, so if this length of the group, sorry, if length of the group, current group, if it is greater than the maximum group size that I have found out so far, what do? I update maximum group size to length of this group. So as usual, you have to go and make sure that the maximum group size is set to something. Now instead of setting it to 0, you can actually set it to 1, right? Because any group should have at least one member. So okay, right, now what we have done is we have done this for the leftmost entry in marks. Okay, the first student, which is 10. Now should we stop that? No, right? We should not stop that, because once you have finished it for 10, you should next ask the question for the smaller the next set of students, right? So now 10 is no longer a part of my group, so I can forget about 10 and I can ask, if 20 is the smallest member in my group, what is the largest group that I can have? So I have to repeat the whole process. Okay, I have to repeat this whole process. Till what point do I have to repeat? Okay, I can, to keep things safe, what I can do is I can repeat this as long as this list is non-empty, right? So repeat this while marks is not equal to the empty list, because when your group is empty, when marks is empty, what group can you form, right? So you can't form any group. Okay, so the moment you have a while loop involving list, you have to ask, will this loop terminate? This loop will terminate because you are removing one element in every iteration. In fact, you are removing the minimum element in every iteration, so this while loop will terminate. Finally, you can get out of the while loop and then you can return m group, right? Maximum group size. Okay, so that's a fairly tricky question, very hard question in my opinion. So first of all, let's see if it works fine. Okay, 5 out of 5 private tests have passed. But as I mentioned, it's a very hard problem in my opinion. So I'll quickly go over this. In fact, I'll just delete the whole thing and summarize the solution. First, we extract the marks of the student in a subject. So for student in the scores data set, we get hold of the student's mark in this subject and we add it to a list by doing marks.append of student of subject. Now we sort the marks in ascending order. Okay, we sort the marks in ascending order and we assume that the maximum group size to begin with is 1. Okay, this is what we assume. Now what we do, as long as the list marks is not equal to the empty list, we extract the smallest element in the list. That's the leftmost element, but we can just use start equal to min of marks. That will give us the leftmost entry. The minimum, since it's sorted, this is the leftmost entry. Now we can we can add this to add the student to group. Okay, this is the only student in the current group. Okay, and once we have added the student to the group, we can remove the student from marks. Okay, so we have removed the student and added the student to the group. Now we can iterate through each student in marks. Okay, and ask this question: is the difference between the mark of the student and the first student in the group, is it less than or equal to mark limit? If that is the case, your group with this particular student can be appended to the group. Okay, once you come out of this loop, you can ask if the length of this group is it exceeding the current maximum. If yes, then update the group size. Okay, now all this is done. Once you get out of the loop, while loop, you will have the maximum group size. Okay, so that's the whole idea. Once again, let's run this. All right, so this is really a hard problem. So it was made harder because of the kind of tricky or non-trivial algorithm that we had to use, right? Where we had to sort the list and we had to go through from the left to right. Perhaps easier versions are available, but then this is one way to solve it. Okay, so yeah, we'll stop here.